Okay, in this video we're going to take a look at the elimination by addition method for solving a system of linear equations. So here are our steps that we're going to go through. These are going to make a whole lot more sense once we start working the problem, but just go ahead and write them down so that you've got them in your notes and you're ready to use them when we go into the problems. Multiply one or both equations by a constant so that one variable has opposite coefficients, okay? This is the very first thing that we're going to do, because in order to eliminate something by adding it, we have to have opposite coefficients so that when we add them together, they go to 0. That's the whole point of doing this method. Then once we get them with opposite coefficients, we'll add the equation term by term. That will eliminate the variable that we have opposite coefficients on. We'll solve for the other variable that's left. Then we'll take that number and, just like with substitution method, we'll back substitute that first value into either one of our two equations, it doesn't matter which, then solve for the other variable. Now let's say that the number you get in step 3 right here is a crazy fraction, like, I don't know, 7/11 or something like that, and plugging it back in would be a pain. Then there is an option. You don't have to back substitute. You don't have to do these last two steps here. What you can do instead of that is you can redo steps 1 through 3 and find the other variable that way. Okay, it's perfectly fine to do that. Some people do that all the time. They never back substitute. They just do this. I use it when, like I said, step 3 results in me getting a number that I just do not want to plug back in. I don't want to deal with it. So I'll repeat steps 1 through 3 and solve for the other variable instead. We'll do one of each. The first problem we'll do straight through steps 1 through 5. And then on the second one, I'll do 1 through 3. And then I'll do 1 through 3 a second time to find the second part of the answer. Okay, let's take a look at this first question here. Solve this system by elimination by addition. Okay, now the homework problems are going to tell you, a lot of them are, which method to use. It doesn't matter to me if you use that method or if you decide to do elimination by addition on all of them, or if you want to do substitution on all of them. It doesn't make any difference. Both methods will work for any of the problems that you have. Some methods, in some problems, one method's easier than the other. But you don't have to go by the instructions if you don't want to. If you look at one and go, I think that would be easier to do by substitution, then do it that way, okay? All right, so for this system, I actually already have two x's that have opposite coefficients. I have a negative 6x and I have a 6x. So what I'm going to do is take advantage of that. We won't have to do our first step. I won't have to multiply the two equations by anything. I can just add them together, and we're going to be able to get rid of those x terms. Now, you add in a stack, so it's a good idea to put both equations in ax plus by equals c form. Now, you can use other forms if you like, but this is a good way to get them arranged in the same order so that it's easier to add them together, okay? Because we're going to add term by term. We add the two x terms together, and what happens here is that the negative 6 and 6 add out to 0. Then we add the y's. 3 and 6 will add to 9, and we add the constants. And that's going to turn out to give me negative 27. So I've got 9y is equal to negative 27. Y then will be negative 3. Okay. Now, we can back substitute that into either one of these two equations. It does not matter which one you decide to use. I usually just grab the first one and use it, unless there's some reason why I would prefer to use the second. In this case, it won't make any difference. So we back substitute y equals negative 3. I plugged it in right here, okay? And if I work on that for a minute to solve for x, that's going to give me negative 6x minus 9 equals 21. Add 9 to both sides. Negative 6x is equal to 30. So x is equal to negative 5. And that gives us our x and our y values. Okay, just like with the substitution, we did get one solution right here, so we choose that button. And then we will type in -5, comma, -3. Be sure you type it in as an ordered pair. It won't take them without the parentheses. The no solution and infinite number of solutions options I will talk about in the last video that I'm going to do on this section, okay? All right, let's do the one. This one's a little bit trickier. Here we are going to have to do step 1, where we figure out what we need to multiply both equations by. What I usually suggest is choose the variable you want to get rid of first, then decide what you need to multiply by. And your goal, remember, is to get the same number but opposite signs on the two variable terms. Now, we do actually already have opposite signs on our y's, so why don't we take advantage of that and use that this first time? Picking the number you multiply by is a little bit like finding a least common denominator and figuring out what you need to multiply fractions by to get that least common denominator. You are looking for the least common multiple of the two numbers that are already there. Sometimes this is easier to do than others. In this particular case, we're going to wind up just multiplying 3 times 10 and getting 30. Okay, so to get 30 on each one of those, I'll need to multiply the first equation by 10 and the second equation by 3. And that will give us 20x plus 30y equals -160. And it will give us 15x minus 30y, those will add out to 0 here in a second, equals 90. So we add those two equations together just like we did in the previous problem. That's going to give us 35x. The y's go to 0. 30 minus 30 is 0. Equals -70. So x is equal to -2. Now we can back substitute that like we did on the last problem, but I'm going to go ahead and show you what the alternative is. I know that -2 is an easy number to plug back in, so I normally wouldn't do this, but if you do get a fraction or something else you just don't want to deal with plugging back in, the other option is to start over, and this time instead of getting rid of y, get rid of x. That will force it to solve for y, and that'll give you your other ordered pair, your other coordinates, I'm sorry. All right, so this time we concentrate on the x column, okay? I don't have opposite signs. I don't have any common factors, so the least common multiple of 5 and 2 is going to be 10, all right? So I need to multiply the top by whatever would give me 10x. That's just going to be a 5. And then the bottom, I'll need to multiply by 2. I need to pick one or the other to be the negative. I'm going to choose to make the second one negative. You could put it in with a 5. It wouldn't make any difference. As long as one of them's negative and one of them's positive, it does not matter. So that's going to give me 10x plus 15y is equal to -80. Multiply the 5 all the way through. And then we get -10x plus 20y is equal to -60. So we are going to have the x's will go to 0. The y's give us 35y. There's that 35 again. If we combine these two negative constants, we get -140. So y is going to be equal to -4. All right. Okay, so our answer here is going to be -2, -4.